Ranjan Kumar Yadav.
हेलो यस सर।
Now
सर आवाज
start
आ
your
रही है आज?
presentation.
थैंक यू
Yes.
सर।
Now start your presentation.
ओके सर। सर स्क्रीन विजिबल है?
हाँ, थोड़ा सा और वाइड करें, बड़ा करें.
ओके। गुड आफ्टरनून सर।
Good
सर टुडेज
afternoon.
माय टॉपिक इज विंडोज ऑपरेटिंग सिस्टम।
Okay. Now start.
यस सर, गिव मी अ सेकंड। सर बिफोर गोइंग टू विंडोज ऑपरेटिंग सिस्टम, let us understand what is operating system. An operating system is a software which acts as an interface between the end user and computer hardware. Every computer must have at least one OS to run other programs. An application like Chrome, MS Word, Game needs some environment in which it will run and perform its tasks. It helps to communicate with computer without knowing their languages. There are various type of operating system. Among them, Microsoft Windows is widely used operating system. Let us check why it is so. Microsoft introduced an operating environment named Windows on 20 November 1985 as a graphical operating system shell for MS-DOS in response to the growing interest in graphical user interface. Microsoft Windows came to dominate the world's personal computer market with over 90% market share, overtaking Mac OS, which had been introduced in 1984. The first version of Windows is Windows 1.0 and the latest version in Windows 11, which is came out recently. Nowadays, most PCs are coming with pre-installed Windows OS. This shows the reliability and easy to use of Windows OS. Let us check the functions of Windows operating system. Functions are process management, memory management, file management, security, command interpretation, job accounting, communication management. Let us check these functions one by one. First, process management. Windows is a primitive multitasking multi-thread operating system. Process in Windows NT-derived OS require at least one thread of execution. By default, a process contains one thread which is composed of a unique identifier, contents of volatile set of registers indicating process states, two stacks used during the thread's execution, private storage are used by subsystems and dynamic link libraries. Memory management. Windows has both physical and virtual memory. Memory is managed in pages with process demanding it as necessary. Memory pages are 4 KB in size. On 32-bit architectures, the total addressable memory is 4 GB divided equally into user space and system space. But on 64 GB architecture, within a process, virtual memory is broken into three categories. First, private virtual memory, that which is not shared, such as the process heap. Second, shareable memory mapped files. And third, free memory with which is not yet undefined use. File management. The Microsoft Windows File Manager is the graphical user interface through which end users could see and manipulate files and folders on early versions Windows computer. In actual practice, the file manager proved to be a powerful and intuitive move away from traditional DOS command line interface. Users could view the computer's directory structure in a left window, while the file and subfolder contents of the selected directory would appear in the right window. End users could then move, copy, rename, print, delete, and search files and folders. Users could also define the attributes for files and folders such as read-only system, hidden or archive, and make associations between file and application. Windows File Manager also used to format disk and manage network file sharing. Now security. Security model protects the data and information of a computer system against malware, threat, and authorized access. As its start, the Windows OS was not known for the security. Starting in Windows NT with its NTFS file system, Windows has grown into reliably secure OS. Windows does still leave itself open to more attacks by allowing the open development and use of third-party applications. With every update, though more security decisions are being made default, making every Windows system more secure. And the last one is input and output components. The design goals for the Windows input and output system are to provide an abstractions of devices, both hardware and software, to application with the following features: uniform security and naming across devices to protect shareable resources, high performance asynchronous packet based input and output to allow for the implementation of scalable applications, services that allow drivers to be written in a high level language and easily ported between different machine architecture. That's all for this, sir. Thank you, sir.
Okay, thank you. Nice.
Sir, sir, will सर आपकी आवाज नहीं आ रही है.
So actually, your mic is turned off.
हाँ बता.
हो सर की आवाज आ रही है तुम लोगों को?
नहीं।
सर ने अपना माइक ऑफ कर रखा है।
किस किस की हो चुकी है?
हाँ, अक्षत जायसवाल। अक्षत जायसवाल, आर यू हियर?
Yes, sir. Am I audible?
अक्षत जायसवाल।
Am I
हाँ,
audible?
नाउ स्टार्ट योर प्रेजेंटेशन। हाँ, ऑडिएबल। यस।
Is my screen visible? Sir?
हाँ, इट्स विजिबल।
Hello. Good afternoon, sir, and everyone. My name is Akshay Jaiswal, and I am going to give my presentation. Sir, wait a second. Sir, is my screen visible? Sir?
क्या हुआ अक्षत? हेलो।
Sir, कुछ इशू हुआ है ठीक में।
अच्छा, तो आप उसको रिजॉल्व करिए। नेक्स्ट स्टार्ट कर अनन्या सिंह।
Yes, sir.
हाँ, नाउ स्टार्ट योर प्रेजेंटेशन।
Sir, is it visible?
Yeah, visual. Now start.
Good afternoon, sir, and hello everyone. I'm Ananya. I'm going to introduce you to the topic of coordinate map. I've covered the basic in this PPT. First of all, what is coordinate map? Well, it's simply a method of minimizing Boolean expressions. A K-map is a graphical method to obtain most simplified form of an expression in a standard form. Now, what's max term and min term? Max term and min terms are generally the terms to assign the values of SOP and POS. Max terms are the sum of literals, and similarly, min terms are the product of all literals. In SOP, we use min terms, the products, and in POS, we use the max term, the addition. Now, coming to the types of Boolean expression, there are two types, SOP and POS. In this slide, I'm explaining SOP, sum of product. In SOP, different product inputs are being added together. The input first passes through the and then OR to yield the output. Now, in this slide, I've given an example of three variable SOP. The three variables are here A, B, C. Here, the number of variable is 3, and hence the number of cell is 2 to the power 3, which is equal to 8. Similarly, if the number of variable is 4, the cell would be 2 to the power 4, which is equal to 16. The K-map is filled by using zeros and ones according to their types. They are solved by making groups. Now we can see its SOP, and hence we will fill the cell with 1 respective to their mean terms. Next, we create rectangular groups of 2, 4, 8 and consecutive terms. With the help of these groups, we find product terms and then sum them up. In this example, I've used 1 to cover all the mean terms. From red group, we get the product term as A-C. From the green group, we get the product term AB. And summing these product terms, we get the final expression as A-C plus AB. Coming to the next slide, I've shown many examples of three variable SOP. In this slide, it's a 4 variable K-map of POS. It's represented in an array of 16 cells. From the red group, we get a product term as QS. It's basically a quad. The red group is a quad, and all these green groups, they are also a quad. They are covered by using rolling of the map. From the green group, we get product term Q dash S dash, and summing this product term, we get the final expression as QS plus Q dash S dash. And now in this slide, I've shown some more examples of 4 variable SOP. Now coming to the second type of Boolean expression, it's product of sum. In POS, product of dissimilar sum of inputs are taken using logical Boolean and or gates. In POS, we will use max term, sum of all literals. Here's come an example of POS. It's a 3 variable POS, an array of 2 to the power 3, which is equal to 8 cells. First of all, we will fill the cells of we will fill the cells of POS with 0 respective to their max terms. Now we create rectangular groups as we did in SOP form. With the help of these groups, we will find the simplified form of the expression. From the red group, we get the term A dash plus B dash. From the maroon group, we get the term B dash plus C dash. And from the yellow group, we get the sum term as A plus B plus C. Now, producting this sum term, we get the final expression as A dash plus B dash dot B dash plus C dash dot A plus B plus C. And here's an 4 variable POS. From the red group, we get the term C plus D dash plus B dash. From the green group, we get the sum term as C plus D dash plus A. Similarly, from the yellow group, C plus D plus A dash. And producting these all terms, we get the minimized expression as C plus D dash plus B dash dot C plus D dash plus A dot C plus D plus A dash. Now here's come the redundant group. It's simply a group which already been covered into different groups. So we simply ignore them. Thank you, sir.
Okay, Ananya,
Yes, sir.
close and open your video.
Yes, sir.
Yes, okay, now close it. Okay, next one.
सर मैं दे सकता हूँ प्रेजेंटेशन?
Uh, किसका था पहले जो नहीं हो रहा था वो?
अक्षय जायसवाल।
हाँ, इस नाउ यू आर रेडी?
यस सर।
चलिए स्टार्ट करिए। अच्छा,
Good afternoon, sir, and everyone. My name is Akshay Jaiswal, and I am going to give presentation on topic components of computer based on hardware and software. First, we will discuss about the definition of hardware. Computer hardware includes the physical part of the computer, such as the case, CPU, monitor, mouse, keyboard, etc. Components of computer hardware. The main things that comprises a computer are motherboard, CPU, GPU, RAM, and hard disk drives for the storage of all data. We will discuss about the components of the computer now. Motherboard. A motherboard is a circuit board through which all the different components of a computer communication and it keeps everything together, and the input and output devices are plugged into the motherboard for functions. Input output units. Input units. Computer responds to the commands given to them in the form of numbers, alphabets, images, etc. through input units or devices like keyboard, joysticks, etc. These inputs are then processed and converted to computer language, and then the response is the output in the language that we understand or one we have programmed the computer with. Output unit. The result of the command we provide the computer with through the input is called the output. The most used is the monitor, since we give commands using the keyboards, and after the processing the results or the outcome is displayed on the monitor. CPU. The CPU is called the brain of the computer, since no action can take place without its permission and execution. As the main processing unit, it communicates with all the other components of the computer, and has three components that helps in the smoothing function of CPU. GPU. The another vital component of hardware is GPU. The graphics processing unit or the video card helps generate high-end visuals like the ones in the video games. Good graphics like these are also helpful for pupils who have to execute the work through images like 3D modelers and others who use the resources intensive software in generally communications directly by the monitor. RAM. The RAM is the most commonly referred component in a computer. The RAM is also known as a volatile memory, since it gets erased every time the computer restarts. It stores the data regarding the programs, which are the frequently accessed programs and processes. It helps the program to start up and close quickly. If it being slower has made it more obsolete these days. Storage unit. Thus, the computer needs to store all their data, and they have either a hard disk drive or a solid state drive for this purpose. Hard disk drive are the disk that stores the data, and this data is read by a mechanical arm. Solid state drives are like SIM cards in mobile phones. They have no moving parts, are are faster than hard drives. There is no need of mechanical arms to find data on physical location and on the drive, and therefore this takes no time at all. Definition of software. The software are the set of instructions that tells a computer what to do. Software comprises the entire set of programs, procedures, and routines associated with the operation of computer systems. The software components are part of the computer system, computer application. Components are means of breaking the complexity of the software into manageable parts. This reduces the complexity of the software development, maintenance, and operation, and support and allow the same code to be reused in many parts. There are mainly five. There are mainly five components of software. First, OS. Operating system is a type of a system software kernel that sits between the computer hardware and the end user. It is installed first on the computer to allow devices and applications to be identified and therefore functional. System software is the first layer of the software to be loaded into the memory every time a computer is powered up. Now, the device driver. Device driver is a type of software system software which bring computer devices and peripherals to life. Drivers make it possible for all connected components or external adds-on to perform their intended task and as directed by the OS. Without drivers, the OS would not assign their any duty. For example, mouse and keyboard, etc. Firmware. It is an operational software embedded within a flash, ROM or EPROM memory chips or for the OS to identify it. It is directly manages and controls all the activities of any single hardware. Traditionally, firmware used to mean fixed software as denoted by wordframe. It is installed on non-volatile chips and could be upgraded only by swapping them with new pre-programmed chips. Utilities. Utilities are the types of system software which sits between a system and application software. These are the programs intended for the diagnostic and maintenance task for the computer. They come in handy to ensure the computer functions optimally. Their tasks vary from crucial data securities to disk drive deformation. Examples and features of the utilities software includes antivirus and security software for the security of files and applications. For example, Malwarebytes, Microsoft Security Essentials, and AVG. Disk partition services such as Window Disk Management and Partition Magic, etc. Programming language translator. These are intermediate programs read on by their software programs to translate high-level languages source code to machine language code. The former is a collection of a programming language that can be that are easy for humans to comprehend and code. That is Java, C++, Python, PHP Basic. The latter is a complex code only understood by the processor. Proper translator languages are compiler, assembler, and interpreter. They are usually designed by the computer manufacturers. Translators programs may perform a complete transmission of program codes and or translate every other instructions at a time. Thank you.
Okay, open your video. Okay, now close it. Next, Kanchan Saxena.
Yes, sir.
Okay, are you ready?
Yes, sir.
Okay, now share screen and start your presentation.
So is it visible?
Yeah.
Okay. Good morning, sir. Good morning, everyone. My name is Kanchan Saxena, and I'm here to explain you on my presentation on the topic of classification of computers on the basis of their hardware design and their size. So first we'll discuss about the type of computers on the basis of their size. On the basis of their size, the computers are classified into four categories, namely microcomputers, mini computers, mainframe computers, supercomputers. First, let's talk about the microcomputers. They are the widely used, cheapest, and fastest growing computers. They are specially designed for general purpose usage like education, entertainment, and in offices for word processing, managing database or spreadsheets and graphics. The examples of microcomputers are desktop computer, laptop, gaming consoles, sound navigation system of a car, personal digital assistants, tablets, and smartphones, etc. Now we'll discuss the few important characteristics of microcomputers. They use single microprocessor, data memory, IO buses, etc. They are capable of performing arithmetic and logical operations. They are slower than other three types of the computers. They use tapes and disks as storage devices. The storage capacity of these computers is in gigabytes, small in size and thus portable. They are easy to operate and uh, quite reliable in terms of the cost. They support single users. The second type of computer is mini computer. These are also called mid-range servers. They offer most features and capabilities that large computers generally do. They are more powerful computers than microcomputers in terms of processing power and capabilities. They are primarily used for process control in scientific firms, manufacturing plants, performing financial and administrative tasks such as word processing and accounting, etc. The important characteristics of many computers are they composed of double processing optimization. They use multiple processors, mainly support a multi-user system, and they are capable of for multiprocessing. The storage capacity is measured in terabyte, which is quite larger than m- microcomputers. They use magnetic disks and tapes for secondary storage. They are even capable of handling more input-output devices. Examples of mini computers are PDP-11, VAX, 7, 7500 Magnum, etc. The third type of computer is mainframe computer. For mainframe computers, very sophisticated operating systems are needed to control and supervise their operations. They are used by large organizations such as banks, hospitals, railways, etc. for online processing, transactions, and massive data storage. The important characteristics of mainframe computer are they are very they have very large storage capacity and memory. As compared to mini computers, they use multiple magnetic disk drives as their secondary storage devices. They use uh, multiple users to operate the system. They support multi-programming and multiprocessing. They can have multiple operating systems. They have performance measured in millions of instructions per second, which is quite high. They perform tasks on huge amounts of external data. They are flexible even to run many kinds of applications, tackle broad business tasks, hence are very बाबू बाहर गए आप काकू प्रियांक यार इसको बाहर लेके जाओ sorry sir. The important characteristics of mainframe computers. Oh god. So can I give it later on?
Okay.
अरे यार क्या प्रेजेंटेशन चल रही है दीदी. Sir, can I continue now?
Yes.
Okay. The the important characteristics of mainframe computers are they are very they perform tasks on huge amount of external data and are flexible even to run many kinds of applications, tackle broad business tasks, and hence are very expensive. The examples of mainframe computers are ICL-39, CDC 6600, VAX 8842, IBM 3090/600, and IBM 4381, etc. Now, the fourth kind of computers are supercomputers. These are the most powerful computers among digital computers. They are used for the purpose of weather forecasting, nuclear science research, aerodynamic modeling, seismology, meteorology. They are often a cluster or grid of smaller computers working together on whatever problem they are looking to solve. The examples of supercomputer are Cray X MP14, CDC 205, ETA GF10, FUZITSU VP400, Next SX2, Param, Ace, Cray 6600. Cray 6600 is the world's first supercomputer invented by Seymour Cray, and the important characteristics of supercomputer are they are fastest among all other computers. They possess very high storage capacity and high productivity. They support multi-users and parallel processing. They have performance measured in floating point operations per second. They execute complicated computations using large memory. They have dedicated purpose for tasks like scientific research or engineering models. Now, the second type of classifications is based on the hardware design. On the basis of hardware design, the computers are categorized into the following three categories. First, analog computers. Second one is digital computers, and third one is hybrid computers. The first category is analog computer. Uh, Analog computer is basically a computer in which numerical data are represented by electrical voltage. In this computer is a form of computer that uses the continuously changeable aspects of physical phenomenon such as electrical, mechanical quantities to model the problem being solved. As mechanical computers used in World War II for controlling the gunfire. Analog computers are also used in science and industries. Analog computers deal with the measurement of data. Examples of analog computers are thermometers because it measures the length of a mercury column which varies continuously. Analog clock, car speedometer, etc. The second category is digital computers. Digital computer is an electronic computing machine that uses the binary digits, bits 0 and 1 to represent all forms of information internally in digital form. Every computer has a set of instructions that define the basic functions it can perform. Sequence of these instructions constitute machine language, low-level language in the form of O's and ones, programs that can be stored in the computers. Example of digital computers are calculator, a small computer, digital clock, digital watches, weighing machines, consumer electronic equipment such as microwave oven, automobiles, mini, micro, mainframe, and supercomputers are also fall under the category of digital computers. Now we'll discuss the differences between analog and digital computer. In uh, analog computers work with continuous values while digital computers work with discrete values. It can only work with digits. It Analog computers can perform certain type of calculations while digital computers uh, speed of calculation is very high. Analog computer is difficult to use and has limited memory and no state, while digital computers are easy to use and has high storage and two states. Analog computers are used in engineering and scientific applications for calculation and measurement of physical quantities such as weight, height, temperature, and speed, while digital computers are widely used to calculate mathematical and logical operations. Analog computers has high accuracy, while digital computers have comparatively low accuracy. Analog computers' readability is low, while digital computers' readability is high. And in analog computer, the examples are thermometer, analog clock, older weighing machines, car speedometers, etc. While for digital computer, the examples are digital watches, microcomputer, mainframe computer, weighing machines, mini computers, etc. Now, the third category of computer is hybrid computer. Hybrid computers are computers that exhibit features of analog as well as of digital computers. The digital components normally serve as the controller and provides logical operations. The analog components normally serve as a solver of differential equations. The examples of hybrid computers are is an example of hybrid computer is a cement plant where all calculations are made by digital systems and accordingly actions such as increase of certain material in the furnace and increase or decrease of a fuel or temperature is performed by with the help of analog system. This is all about my presentation. Thank you.
Okay, now open your video.
So it's done now.
Okay. Okay, thank you. Now close it. Next, Saswat Raj.
Yes, sir. Am I audible, sir?
Yeah.
Okay, sir. Sir, is it visible? Which I'm showing.
Yeah.
Okay, good afternoon, everyone. Good afternoon to sir and everyone. My name is Shashwat Raj, and today we are all going to learn something about number systems and their conversion. We will divide this into three parts. First, number. Second is number systems, and third is conversions, as we can see from the title. Now, first of all, we will understand what is a number. We will go by the definition. The definition states that a number is a mathematical value used for counting and measuring objects and for performing arithmetic calculations. In a simple term, I would say that everything which we see around is described in the form of numbers only. Right now, we can see that there are around 30 participants in the Google Meet. This 30 is a number. The time in our watches, the things which we see nearby us, they all are numbers only. And number plays a crucial role in representing anything around our world. This is not working. Wait. I have to start one. Okay. Numbers are basically of in the real system, we see that there are 2 to 3 types of numbers: natural numbers, whole numbers, real numbers, irrational numbers, which we study in mathematics. But when we go on to further classes, like in the computer science, we see that there are more different types of numbers. Or particularly, we should say number systems as decimal number system, binary number system, octal number system, hexadecimal number system. The question arises, what is a number system? A number system is defined as a representation of numbers by using digits or other symbols in a consistent manner. The value of any digit in a number can be determined by a digit, its position in the number, and the base of the number system. The numbers are represented in a unique manner and allow us to operate arithmetic operations like addition, subtraction, and division. In simple terms, it is like the alphabet. In the case of alphabet, we see A, B, C, D. This is the alphabet of the language. Same as the number system is the alphabet of the numbers. We represent by symbols in different kinds: 1, 2, 3, 0, 1, etc., etc. The importance of numbers, we all must be agreeing, is that in the digital era currently which we are facing, all the world's data is represented by only mere 2 numbers, 0 and 1. Now coming on types of number systems, which we will study in detail. First is the binary number system, which I just mentioned, which has a base 2. The definition states that the binary number system uses only 2 digits, 0 and 1. The numbers in this system have a base of 2. Digits 0 and 1 are called bits, and 8 bits together make a byte. The data in computers is stored in the terms of bits and bytes. The machine language is made of binary language only. The binary number system does not deal with any other digits such as 2, 3, 4, 5, and so on, which we are more commonly associated with. Some examples which we can see on the screen. Next is the decimal number system, which we have studied since very small and we are most familiar in the real life. it has a base 10. The decimal number system uses 10 digits 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9 with the base number as 10. As I said, the decimal number system is a system that we generally use to represent numbers in real life. If any number is represented without a base, it means that its base is 10. These are some of the examples on the screen which we can see about the decimal number system. Next comes the octal number system. The octal number system uses 8 digits 0, 1, 2, 3, 4, 5, 6 and 7 with the base of 8. The advantage of the system is that it has lesser digits when compared to several other systems. Hence, there would be fewer computational errors. Digits like 8 and 9 are not included in the octal number system. Just as a binary, the octal number system is used in mini computers, but with digits from 0 to 7. The hexadecimal number system uses 16 digits. There are also alphabets included 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and subsequent digits which are represented by alphabets are A, B, C, D, E, F. Here A to F is the hexadecimal number system, means the numbers 10 to 15 of the decimal number system respectively. This system is used in computers to reduce the large size strings of the binary system. These are some of the examples which we see in the hexadecimal number system. So we have covered number and number systems. Now the need is for conversion. We see that we have four types of hexadecimal, octal, decimal and binary. But often where the most suitable required decimal number system is there, we have to operate with that system. So the need for conversion arises. Like we commonly use a decimal language, but when we are putting in the computer does not understand decimal language. So obviously there is a need for converting decimal language to binary language. So here the need for conversion arises. Now we will understand in detail conversion between number systems. First, conversion from any other number system to decimal number system. It can be binary, octal or hexadecimal. Step 1 will be, you have to identify the base of the number. For binary it will be 2, for octal it will be 8, for hexadecimal it will be 16. Now multiply each digit of the given number starting from the rightmost digit, from the exponents of the base. The exponent should start with 0 and simply increase by 1 as we move from right to left. We simplify each of the above products and add them. The sum which will come is the equivalent number in the decimal number system of the given number. I will show you an example. Here we can see that we have taken a binary number 100,111. Now I have given this with the figure. The rightmost digit, which is the 1 in the red painted, we have multiplied it by 2 to the power 0 as the base is 2 in the binary, and we will start with power from 0 to 1, 0 and then increasing. So 2 to the power 0, this is 1 into 1 equals to 1. Similarly, we perform the calculations and we add all of them on the right hand side, and we see 32 plus 4 plus 2 plus 1, which equals 39. This is an example of conversion of binary number to a decimal number. Same process can be applied with different base. For octal it will be 2 to the 8 to the power 0, 8 to the power 1 and so on, and similarly for hexadecimal system. Now conversion of decimal number system to any other binary, octal or hexadecimal number system, the reverse which we have just studied. First step will be again identifying the base of the required number. Divide the given number by the base of the required number and note down the quotient and the remainder in the quotient remainder form. Repeat this process until we get the quotient less than the base. The number in the converted system is obtained by reading all the numbers and the last quotient, which is important, from bottom to top. The bottom to top is the most significant digit. We can see an example here. 4320 is a decimal number. Now we are converting it into an octal number. So we start, as we said, we will identify the base of the required number system, which we have to convert, sorry. So 8 is that number, which octal number system has 8 as a base. So we will divide the decimal number by 8. We will keep on progressing until we get the last number as 10, and we will go from bottom to top 10340. Another example on the right hand side is conversion of 700 decimal number to hexadecimal number system. We can see that the alphabets appear because hexadecimal number system uses alphabets. In the case of converting any one number system which is not decimal, like the binary, octal or hexadecimal, to another number system, we don't have any major processes of doing it. So what we do conveniently is we convert first the number to a decimal number system, then we convert into the required number system. However, I had included in my assignment few methods. I would like to enunciate them, like from binary to octal. Okay, I think this is over. So, okay. No. So is this visible, which I am showing right now?
Yeah.
Okay. So here I have written that, for example, we have to convert binary to octal or binary to hexadecimal. So what we do that we convert, we group the binary digits. For example, I will write this. Suppose I have 1, 0. Okay, we will take this only. So what happens? We will yes, we will take group from the rightmost side. We will take one group, and we will took three digit group, and then convert into an equivalent octal number, whatever it is. Then we will also take 3 another group, and we will convert into an octal number. And similarly, if there was like say there was only one digit, so we will additionally make imaginary zeros which will not change the value, and we will take another octal number. This way we will get some octal number, and the equivalent to that only that group, and we will write them together, and this will convert into an octal number. Same is the process for hexadecimal number. For hexadecimal number, what we will do, suppose this is again coming with us 1 2 3 4. This is the number. So what we will do, we will make a group of 4 here, and we will convert into an equivalent hexadecimal system, whatever is the hexadecimal system number for that. And there was one more. So and this 4 group we will make for another hexadecimal number, and we will write these 2 alphabets, whatever we will get, and we will get the required hexadecimal number. This works. This is a shorter method. For the reverse process, suppose this is the hexadecimal number system. So we will divide this one digit into its 4 subsequent binary number. So we will again get the reverse process, whatever we have done. Same is the option for octal. Sorry. For example, we have done this 7 6 5. So we will first convert 5 into its 3 binary system, binary equivalent, 6 similarly, and then 7. This happens. Now I will come back to my presentation. The last slide was left. Yes. So conclusion is that I will tell you some uses of each number system. The binary number system is used to store data in computers, which we know. Advantages of the octal number system is that it has fewer digits when compared to the several other systems. It is neither too big like hexadecimal system or neither too small like binary number system. Hence, there will be fewer computational errors. The decimal number system is a system we use in daily life. The hexadecimal number system is used in computers to reduce the large size strings of the binary system, because it becomes compact by using alphabets also. Hence, it becomes crucial for us to understand the number systems, their interconnection, interdependence, and conversion. Thank you, sir. That's all.
Okay. Now open your video. Okay. Now close it. Next, Ajay Misra. Sorry, Ayush Misra.
Yes, sir.
Now start your presentation.
Sir, is my screen being shared right now?
Yeah.
Okay, sir. What is this? Yes, sir. So, good afternoon, everyone. Screen visible? Hello. Hello.
Yeah, it's visible.
Okay. So, good afternoon, sir, and my dear batchmates. My name is Ayush Mishra, and today I am here to present my topic of presentation, that is the D Morgan Theorem, before you all. So, starting right off the bat with the history of Augustus D Morgan. Yes, the scientist or the mathematician who gave us this theorem. So, Augustus D Morgan, who died in 1871, was a British mathematician born in India. Yeah, you heard it right, he was born in India and blind in one eye. Great. His father died when he was 10. Sorry for hearing that. Attending Trinity College, Cambridge at age 16, and was appointed professor of mathematics at the newly founded London University at age 22. He wrote widely on many mathematical subjects, including logic, algebra, and paradoxes. De Morgan's crater on the moon is also named after him, and he proposed a riddle for the year of his birth, that is x, that I am x years of age in the year x squared. Riddle for you all. Here he is. Okay, so what is the De Morgan's theorem? De Morgan theorem is crucially important in solving various kinds of Boolean algebraic expressions. These laws are pair of transformation principles used in solving complicated logical expressions in high circuit designs and in computer programming. This theorem states the similarity between gates that have identical inverted input and output. Okay, so De Morgan has two laws. De Morgan's first theorem states it defines that the inverted result from AND operation is the same as the OR operation and the complement of each variable where the result equals NAND operation. I'm really sorry for using this really unlucid definition right there. That is x dot y complement is equal to x complement plus y complement. The Morgan's theorem, the equation of it is as easy as ABC. All you have to understand is the basic phrase that says that break the line, change the sign. Okay. Yeah, the theorem can be verified using the truth table and logic gates. Okay, so truth table is basically one of the most elegant and the simplest form or the process of actually proving any Boolean expression, as long as it is not very difficult or very complicated. You can simplify the expression and you can verify it using the truth table. We have the truth table here. We have the input variables, the x and the y column, and you can see here this particular column and this particular column are equal. Okay, this proves that the De Morgan theorem holds true. We have in this column x dot y complement and in this column x complement plus y complement. So that is how we have proved the De Morgan's theorem using the truth table. Okay, so this right here is the representation of the De Morgan's theorem using logic gates. The first one on the left is the x y dot, that is the AND gate, which is then is being complemented by the NOT gate, x y bar. And the second is the x bar and the y bar using the NOR gates, the inputs we have, and then the OR gate, that is x bar plus y bar. The logic gate of De Morgan's first law, these are two. In the above diagram, the first logic gate arrangement, x dot y complement, is implemented by a NAND gate. Yes, this particular first gate is also known as the NAND gate. Is initially inverts both the inputs and the inverted results are provided as input to the OR gates. So the final output is x bar plus y bar. Therefore, it is observed that the NAND gate function is equal to the OR gate function having both inputs as inverted. Moving further. Yes, now we have the De Morgan's second theorem. The second theorem of De Morgan's law defines that the inverted result from OR operation is the same as the AND operation of a complement of each variable where the result equals NOR operation. That means the De Morgan's second theorem is x plus y naught is equal to x bar dot y bar. As I told you earlier, that it is nothing but break the line, change the sign. We have converted plus to and then the complement is being distributed among the variables individually. We have the truth table for this proof also. As I told you that all the De Morgan's theorem, or in fact any algebraic expression, can be proved using the truth table. Here again the column number 4 and the last column are equal, showing that the De Morgan's theorem for this also holds true. Here is the logic gate of the De Morgan's second theorem, that is x and y OR, using the OR gate. Now the first gate right here on the left is actually nothing but the NOR gate also. Okay, and the second gate is the equivalence of this first gate. In the above given diagram, the first logic gate arrangement is x plus y complement, that is the NOR gate, and the second logic gate arrangement is initially inverts both the inputs, and the inverted results are provided as the input to the NAND gate. Not much to explain here, it's very easy. Now this particular slide is what we need to understand more deeply and proficiently. The same principle can be applied for both 3 and 4 variables. As until now we have learned that the De Morgan's theorem is holding true for 2 variables, but that is not the case. The De Morgan theorem, which we study in computer fundamentals, was actually derived through set theory, and this holds true for not only 3-4 variables but also n variables. All we need to keep in mind is the basic formula of breaking the line and changing the sign. For example, here we have an example where x dot y dot z whole complement is x complement plus y complement plus z complement. Similarly, with the second theorem of De Morgan's theorem, we have x plus y plus z complement as x complement, y complement and z complement. We can further extend this particular result to n variables and solve accordingly. Okay. Yes, the most major question, that why on earth are we studying De Morgan's theorem, that is we are going to look into its applications. The applications of De Morgan's theorem are crucially observed in multiple domains of engineering and mathematics. Firstly, in the domain of engineering, using De Morgan's law, Boolean expressions can be built easily using through one gate, which is usually NAND or NOR gate. Now this particular first application is the most important application of the De Morgan's theorem. Let's say in fact you want to make a machine. Okay, we need circuits, the ICs. Now instead of using an AND gate and a NOT gate, two gates, we can simply use the NAND gate. And these NAND and NOR gates are known as the universal gates because any fundamental gate can be converted or can be equated to these two gates. Okay, so this, what it results in, is the hardware design at a cheaper cost. It's very logical that the less number of ICs we use, the effective and more cheaper it will be. So this is the first application of De Morgan's theorem. The second is the using the verification of SAS code. Now this SAS code is nothing but a mathematical tool or operator that is used in algebra. Again, the De Morgan theorem is used there for the verification of this code. The implementation in the computer and electrical engineering domain, again in the circuit diagrams. The De Morgan's theorem laws are also employed in Java programming, definitely, because the De Morgan theorem, as I told you, was derived from the mathematical set theory, and thus it has various applications and its vicinity extends all across it in the field of mathematics and algebra, including the Java programming. We have the equivalent gates of De Morgan's laws shown below. That is, we are going to compare some fundamental logic gates with the De Morgan's logic gates. This right here is the AND gate. Next to it is the negative NOR gate. Now these two gates are equivalent to each other. Similarly, these two gates, the NAND gate is equivalent to the negative OR, and the NOR gate is equivalent to the negative AND. All these gates are equivalent and can be proved henceforth by the De Morgan's theorem, the De Morgan's laws. You can use truth table also to verify them. Okay, so here I will take leave, and thank you everyone for listening to my speech and my lousy presentation. Thank you. Thank you, sir.
Oh, okay, now open your video. Okay, now close it. Next one. Shivam Singh Kushwaha.
Yes, sir.
Okay. Now we start presentation.
Is it visible, sir?
Yes, visual.
Okay, sir. Good afternoon to all of you. My name is Shivam Singh Kushwaha, and today I'm going to present a very important concept in Boolean algebra, that is sum of products and
You
product
have
of
not
sums,
shared
also
yet.
called.
Make
Sir,
it
शेयर नहीं
enlarge.
हो रहा क्या?
स्क्रीन enlarge करिए.
वेट अभी भी नहीं लार्ज हुआ सर.
No.
अब हुआ सर?
No. शेयर प्रेजेंटेशन कीजिए. हाँ, अब ठीक है.
अब ठीक है सर.
Yes.
Good morning to all of you. My name is Shivam Singh Kushwaha, and today I'm going to present the very important concept in Boolean algebra, that is sum of products and product of sums, also called SOP and POS. Concept of sum of products SOP mainly includes min terms, type of SOP, K-map, and schematic design of SOP. Similarly, the POS mainly includes the max term, type of POS, K-map, and POS. Expression products in. So min terms can be defined as a product of all the variables, either with the complement or without complement. For example, x complement, y complement, z complement, x complement, y complement, z, etc. Min term can be written as, if the value of the variable is 1, we will take the variable without the complement. For example, if the value of x is 1, then we will write x as it is. If the value of the variable is 0, we will take the variable with complement. For example, if the value of x is 0, then we will write x with the complement sign, x complement. Now this is the truth table for the min term, and in the first row x is 0, y is 0, z is 0. So the min term for this row can be written as x complement, y complement, and z complement, and also m0. Similarly, we can write all the min terms for the respective rows. Now the type of SOPs. There are mainly three types: canonical form and non-canonical SOP and minimal SOP. So, but here we are only focusing on canonical and non-canonical forms. So basically, the non-canonical SOP is a simplified form of canonical SOP. So here the column F shows the result of the particular function. And with the help of result only, we can write the Boolean algebra expression by SOP method. Also, the SOP method deals with the higher values, that is 1. So you can see here both the values, that is 0 and 1, but we are only interested in ones. Now next, the canonical SOP form can be written as F summation m1, m2, m3, m5. By expanding the above summation, we can get the following function, which is F is m1 plus m2 plus m3 plus m5. By substituting the min terms in the above equation, we can get the following. We can get the below expression. Now the following expression is the canonical expression, and when we simplify it, and it gets converted into non-canonical form expression. Now, this is how we simplify this expression to get the final result, and F is the expression which satisfy above column of F function. The main thing we should remember here, that while solving the expression, that the Boolean property, which is z complement plus z, gives you 1. This is a very important property which we'll be using while solving this expression. Now the minimal product of sums, in this we will be using k map method. Now come to the product of sums. Now the short form of the product of sum is POS, and it is a one kind of Boolean algebra expression. In this different sums are being multiplied, and those different sums are max terms. Now max term can be defined as sum of all the given variables either with the complement or without complement. Max term can be written as, if the value of the variable is 1, we will take the variable with complement. For example, if the value of x is 1, then we'll write x as a x complement, and if the value of the variable is 0, will without complement. For example, uh, if the value of x is 0, we'll write x as it is. Now, here is the truth table for max term. In the first row, we have x0, y0, z0. So the max term we can write as x plus y plus z, which is capital M0. Now in the next slide, we'll get to know how the min terms get converted into the max term. So basically, the max term is the complement of min terms. So the capital M3 is the complement of a small m3. So if we take an example, x complement y z, if we just take the complement of whole, we'll get the max term of the respective min terms. And here we are using the De Morgan's law for this. Now the type of product of sums, there are also 3 types: canonical sum of products, non-canonical sum of products, and mixed sum of products. So here also the column F shows the result of the particular function, but here only POS only concerns with the lower values, that is 0. So for the above table, the canonical SOP can be written as F pi M0, M4, M6, M7. By expanding the above equation, we can get the following function: F M0, M4, M6, M7. By substituting the max term in the above equation, we can get the below expression. Now this expression is the canonical form expression and now come to the non-canonical form expression. So this is a way to how to solve the canonical to non-canonical expression. So after this we can get the result. And now next, minimal product of sums. Here we are also using K-map method for this. Now thank you, sir.
Sir, can I present now?
Shivam, open your camera.
Yes, sir. Okay, sir.
Okay, now close it. Next one, Satyendra Kushwaha.
Yes,
Is
sir.
here Satyendra Kushwaha?
Yes, sir.
Okay, now start your presentation.
1 minute, sir. Sir, it is visible. Sir, may I start?
Yeah, now it is visible.
Okay, sir. Good afternoon, sir. Myself Satyendra Kushwaha, and I am going to present on the topic number system and their conversion. Now coming to number system, there are 2 types of number system: non-positional number system, positional number system. Non-positional number system.
थोड़ा तेज बोलो बेटा, loudly.
Characteristics of non-positional number systems are: in non-positional number system, we use symbols such as I for 1, II for 2, I for 3, and etc. Each symbol represents the same value regardless of its position in the number. The symbols are simply added to find out the value of particular number. The difficulty of using non-positional number system is that it is difficult to program arithmetic with such a number system. Now, positional number system. In positional number system, we only use a few symbols which are called as digits. These symbols represent different values depending on the position they occupy in the number. Now, first is decimal number system. Characteristic of decimal number system are: it is a positional number system. It has 10 symbols or digits that are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Hence, its space is 10. Example, it is written. Now, binary number system characteristics are: it is a positional number system. Second, it has two symbols or digits which are 0 and 1. Hence, its space is 2. The maximum value of a single digit is 1. Each position of a digit represents a specific power. The base is 2. This number system is used in computers. Now its example is given, um, which is shown. Now representing numbers in different number system. In order to be specify about which number system we they are referring to, it is a common practice to indicate base as a subscript. Thus, we write 10101 base 2 is equal to 21 base 10. Now, octal number system. Characteristics are: it is a positional number system. It has total 8 symbols or digits that are 0, 1, 2, 3, 4, 5, 6, 7. Hence, its space is 8. The maximum value of a single digit is 7. Each position of a digit represents a specific power of the base, which is 8. Since there are only 8 digits, 3 bits, that is 2 to the power 3 is equal to 8, are sufficient to represent any octal number in binary. Now the example are given: 2057 base 8, that is shown that how we convert it to decimal number system. Now hexadecimal number system, its characteristic is: it is a positional number system. It has total 16 symbols or digits that are 0, 1, 2, 3, 4, 5, 6, 7, and 8, 9, and the alphabets that are A, B, C, D, E, F. Hence, its base is 16. The symbols A, B, C, D, E, and F represent the decimal systems 10, 11, 12, 13, and 14 respectively. The maximum value of a single digit is 15. Each position of a digit represents a specific power of the base, that is 16. Since there are only 16 digits, that is 4 bits, which is written as 2 to the power 4 is equal to 16, that is sufficient to represent any hexadecimal number binary. Now its example is given, that is shown as 1AF base 16, that is shown how to convert it to a decimal number system, that is 431 base 10. Now coming to converting a number of another base to a decimal number. This is a method. Step 1 is determine the column or the positional value of each digit. Step 2, multiply the obtained column values by the digits in the corresponding columns. The step 3, calculate the sum of these projects. Now it is shown how to convert a number to another base of decimal system. It is example where it is shown that number 4706 base 8 is converting to base 10. Now there is another example which shows how to convert a decimal number to another base. Here it is written number 952 base 10, and that we have to convert to base 8. Thank you, sir.
Okay, now open your video. Okay, now close it. Next, Abhay Misra.
Is it visible, sir?
Yeah.
Honorable sir, and my dear friends, a very pleasant afternoon to all of you present over here. This is Abhay, and I'm going to show my presentation on the topic types of secondary storage. Firstly, I'm going to explain what is secondary storage device. A secondary storage device refers to any non-volatile storage device that is internally or external to the computer. The secondary storage media can be fixed or removable. Fixed storage media is an internal storage medium, like a hard disk that is fixed inside the computer. Now I'm just showing some characteristics of secondary storage device. There are some characteristics of secondary memories which distinguish it from primary memories, such as it is non-volatile, which means it retains data when power is switched off. Second, it allows for the storage of data ranging from a few megabyte to petabyte, and it is cheaper as compared to primary memories. Secondary storage devices like CDs and flash drives can transfer the data from one device to another. Now I'm just talking about the types of secondary storage device. There are two types of secondary storage device: fixed storage and removable storage. Now we are going to talk about fixed storage. Fixed storage is an internal device used by a computer system to store data. Usually, these are referred to as the fixed disk drive or hard disk. Fixed storage devices are not fixed. These can be removed from the system for repairing work, maintenance purposes, and also for an upgrade, etc. But in general, this cannot be done without a proper toolkit to open up the computer system to provide physical access, which means to be done by an engineer. Technically, almost all data that is being processed by on a computer system is stored on some built-in fixed storage device. We have the following types of fixed storage. Now we are going to talk about removable storage. Removable storage is an external media device that is used by a computer system to store data. Usually, these are referred to as the removable disk drives or external drives. Removable storage is any storage device that can be removed from a computer system while the system is running. Examples of external devices include CDs, DVDs, Blu-ray disk drives, and disklets, and USB drives. Removable storage makes it easier for a user to transfer data from one computer system to another. The main benefit of removable disks is in storage factors is that they can provide the fast data transfer rates associated with the storage area network. We have the following types of removable storage. Now I have classified the secondary storage devices in a flowchart. Classification of secondary storage device. Secondary storage devices are divided into two types: sequential access device and direct access. In sequential access device, we have magnetic tape, and now we are talking about direct access device. It is divided into three categories: magnetic disk, optical disk, and memory storages. Magnetic disks are divided into two: floppy disk, hard disk. Optical disks are categorized into four: CD-ROM, WOM, CD-RW, DVD. Memory storage devices are categorized into two types: flash drive, memory card. This was my presentation. Thank you, sir.
Okay, open your camera. Okay, now close it. Okay. Next,
Thank you, sir.
Vishrut.
Yes, sir.
Okay, now start your presentation.
So is it visible?
Yeah.
Good
Hierarchies of
afternoon.
memory.
Yes, sir. Yes, sir. Good afternoon,
Yeah.
everyone. My topic is hierarchies of memory. The points that I'm going to cover in this PowerPoint are what is memory hierarchy in computer architecture, characteristics of memory hierarchy design, advantages of memory hierarchy. What is memory hierarchy? As some of us may know that memory is divided into 5 categories, or we can call it hierarchies, based on the speed, use, as well as the response time. The processor can move from one level to another based on its requirements. The 5 hierarchies in the memory are registers, cache, main memory, magnetic disks, and magnetic tapes. The first 3 hierarchies are volatile memories, which mean that there is no power and then automatically lose their stored data, whereas the last 2 hierarchies are non-volatile, which means they store the data permanently. A memory element is the set of storage devices which store the binary data in the type of bits. In general, the storage of memory can be classified into 2 categories, such as volatile as well as non-volatile. Memory hierarchy in computer architecture. The memory hierarchy design in a computer system mainly includes the different storage devices. Most of the computers were inbuilt with extra storage to run more powerfully beyond the main memory capacity. The following memory hierarchy diagram is a hierarchical pyramid for computer memory. This is a pictorial representation of the memory hierarchical diagram. The the following the designing of the memory hierarchy is divided into 2 types, such as primary or internal memory and secondary or external memory. Primary memory is accessible by the processor straightly. This memory includes main cache as well as CPU registers. Secondary memory is accessible by the processor through an input-output module. This memory includes an optical disc, magnetic disc, and magnetic tape. Characteristics of memory hierarchy. The memory hierarchy characteristics mainly include the following: performance, ability, access time, and cost per bit. Performance. Previously, the designing of a computer system was done without the memory hierarchy, and the speed gap among the main memory as well as the CPU registers enhances because of the huge disparity in access time, which will cause the lower performance of the system. So the enhancement was mandatory. The enhancement of this was designed in the memory hierarchy model due to the system's performance increase. Ability. The ability of the memory hierarchy is the total amount of data the memory can store, because whenever we shift from top to bottom inside the memory hierarchy, then the capacity will increase. Access time. The access time in the memory hierarchy is the interval of the time among the data availability as well as request to read or write. Because whenever we shift from top to bottom inside the memory hierarchy, then the access time will increase. Cost per bit. When we shift from bottom to top inside the memory hierarchy, then the cost for each bit will increase, which means an internal memory is expensive compared with external memory. Memory hierarchy design. The memory hierarchy in computers mainly include the following: registers, cache memory, main memory, magnetic disks, and magnetic tape. Registers. Usually the register is a static RAM or SRAM in the processor of the computer, which is used for holding the data word, which is typically 64 or 128 bits. The program counter register is the most important, as well as found in all processors. Most of the processors use a status word register as well as an accumulator. A status word register is used for decision making, and the accumulator is used to store the data like mathematical operation. Cache memory. Cache memory can also be found in the processor. However, rarely it may be another IC, integrated circuit, which is separated into levels. The cache holds the chunk of data which are frequently used from main memory. When the processor has a single core, then it will have two or more cache levels rarely. Present multi-core processors will be having two levels for each one core, and one level is shared. Main memory. The main memory in the computer is nothing but the memory unit in the CPU that communicates directly. It is the main storage unit of the computer. This memory is fast as well as large memory used for storing the data throughout the operations of the computer. This memory is made up of RAM as well as ROM. Magnetic disks. The magnetic disks in the computer are circular plates fabricated of plastic, otherwise metal, by magnetized material. Frequently, two faces of the disk are utilized as well as many disks may be stacked on one spindle by read or write heads obtainable on every plane. All the disks in computer turn jointly at high speed. The tracks in the computer are nothing but bits which are stored within the magnetized plane in spots next to concentric circles. These are usually separated into sections which are named as sectors. Magnetic tape. This tape is a normal magnetic recording which is designed with a slender magnetizable covering on an extended plastic film of the thin strip. This is mainly used to back up huge data when the computer requires to access a strip. First, it will mount to access the data. Once the data is allowed, then it will be unmounted. The access time of memory will be slower within the magnetic strip, as well as it will take a few more minutes for accessing a strip. As you can see, I've sorted out the advantages of memory hierarchy. Memory distributing is simple and economical, removes external destruction. Data can be spread all over, permits demand paging and pre-paging. Swapping will be more proficient. In conclusion, we can say that we can conclude that it is mainly used to decrease the bit cost, access frequency, and to increase the capacity access time. So it will be up to designer how much they need characteristics for satisfying the necessity of the consumers. These are the sites from which I've taken a bit of informations. Thank you.
Okay.
Yes, sir.
Now open camera.
Yes, sir.
Okay. Now close it. Next one, Minachi Sharma.
Hello, sir. Am I audible?
Yeah.
Just a minute,
Start
sir.
your presentation.
Yes, sir. Is the screen visible, sir?
Yeah.
Good morning, everybody. Am I audible?
Yeah.
Good morning, everybody present over here. My name is Meenakshi Sharma. I'm going to give presentation on the topic secondary storage devices. So, secondary storage devices. As we all know, we have read so far the primary memory is volatile and has limited capacity. So, it is important to have another form of memory that has larger storage capacity and from which data and programs are not lost when the computer system is turned off. Such type of memory is called secondary memory. In secondary memory, programs and data are stored. It is also called auxiliary memory. Secondary or external storage devices have a much larger storage capacity and the cost of secondary memory is less as compared to the primary memory. Uses of secondary memory. As we know, the primary memory stores data only when the power supply is on. It loses data when the power is off. So we need secondary memory to store the data permanently even if the power is off. Secondary memory provides large storage space so that we can store large data like videos, images, audios, files, etc. permanently. Some secondary devices are removable so we can easily store or transfer data from one computer device to another. There are two types of secondary storage. One is fixed storage and second one is removable storage. In secondary memory, a fixed storage is internal media device that is used to store data in computer system. Fixed storage is generally known as fixed disk drives or hard drives. Generally, the data of computer system is stored in built-in fixed storage device. Fixed in storage does not mean that you cannot remove them from the computer system. You can remove the fixed storage device for repairing or for maintenance with the help of expert or an engineer. There are types of fixed storage device. First one is internal flash memory, SSD, solid state disk, and hard disk drives. The second type of storage device is removable storage. In secondary memory, the removable storage is an external media device that is used to store data in computer system. Removable storage is generally known as disk drives or external drives. It is a storage device that can be inserted or removed from the computer system according to our requirements. We can easily remove them from the computer system while the computer is running. Removable storage devices are portable, so we can easily transfer the data from one computer to another. Also, removable storage devices provide fast data transfer rates associated with the storage area networks. Types of removable storage are optical disk, memory cards, floppy disk, magnetic tapes, disk packs, paper storage, etc. Here are some secondary memory devices. First one is floppy disk. Floppy disk consists of magnetic disk in a square plastic case. It is used to store data and transfer data from one device to another. To use floppy disk, our computer needs to have a floppy disk drive. This storage becomes absolute now and has been replaced by CDs, DVDs and flash drives. Second one is compact disc, commonly known as CD. It contains tracks and sectors on its surface, having a storage capacity of 700 MB of data only. There are two types of CD. One is CD recordable and another one is CD rewritable. Third comes digital versatile disk, also known as DVD. Looks same as CD, but storage capacity is greater as compared to CD. It can store up to 4.7 GB of data. There are mainly three types of DVD. First one is DVD ROM, digital versatile disk read only. In the DVD ROM, the manufacturer writes the data in it and the user can only read that data, cannot write the new data in it. For example, movie DVD. Movie DVD is already written by manufacturer. We can only watch the movie, but we cannot write new data into it. Second one is DVD-R, that is digital versatile disk recordable. In DVD-R, you can write the data only one time. Once the data has been written onto it, cannot be erased. It can only be read. Third one is digital versatile disk rewritable and erasable. It is a special type of DVD in which data can be erased and rewritten as many times as much as we want. Fourth storage device is Blu-ray disc. Looks like a CD or DVD but can store data and information up to 25 GB. If you want to use Blu-ray disc, you need a Blu-ray reader. Fifth one is hard disk. Hard disk is a part of unit called hard disk drive. Hard disk or hard drives comes in different storage capacities like 256 GB, 500 GB, 1 terabyte and 2 terabyte, etc. There are two types of hard disk. First one is internal hard disk and second one is external hard disk. Sixth one is flash drive. Flash drive or pen drive comes in various storage capacities such as 1 GB, 2 GB, etc. to 1 terabyte. Flash drive is used to transfer data and store data. To use flash drive, we need to plug it into USB port of the computer. As the flash drive is easy to use and compact in size, nowadays it is very popular. Next one is solid state disk, also known as SSD. It is a non-volatile storage device that is used to store data and access data. It is faster, does noiseless operation because it does not contain any moving parts like hard disk, consumes less power, etc. It is a great replacement of standard hard drives in computer and laptops if the price is low, and it is also suitable for tablets, notebooks, etc. because they do not require large storage. The last one is SD card, known as secure digital card. It is generally used in portable devices like mobile phones, cameras, etc. to store data. It is available in different capacities. The data stored in a SD card is stored in the memory chips present on SD card, and it does not contain any moving parts like the hard disk. Thank you. That's all for my presentation. Thank you, everybody.
Okay, now open your camera.
Just a minute, sir.
Okay, now close it. That's next one, Anurag Simwal.
Yes, sir.
Now start your presentation.
Yeah.
Sir, is it visible?
Yeah, yeah, it is visible.
My today's topic is simplification of expressions using Boolean laws. First of all, what is an expression? An expression is a collection of constants which evaluate to a unique value. Is an example of an expression. 2 plus a into 3 minus b. It's a pretty simple expression which we normally use in not only in computer science but also in maths and physics and other subjects. Now, let's talk about Boolean expression. Boolean expressions are formed when we perform Boolean operations on Boolean variables. Consider the following expression: f equals to x plus dash y star z. Here, f is a Boolean expression. All the operators you can see, namely plus, dash, which is also known as negation, and a star, are Boolean operators, and x, y, z are Boolean variables. Boolean operators. Taking the previous example in the previous slide, the operators plus, which is also known as or, and it is also represented by a v sign. The not operator and the and operator are known as Boolean operators. They are used to evaluate Boolean expressions. Boolean laws. The Boolean expressions need to be converted into simplest form for us to use them. They need to be converted from complex expressions to their simplified versions. For example, dash x dot y plus x. This expression is in its complicated form and not simplified. When we simplify it, it gives the output, which is also known as tautology. We will talk about this later on, how it converted and what laws were used in converting this expression. This simplification of Boolean expressions is governed by Boolean laws. These are the most widely used Boolean laws, namely the associative law, the identity law, which states that a and 1. When I say and, it is the Boolean operator which I am talking about. A and 1 equals to a, and a or 0 equals to a. Involution law, which states that double negation equals to the variable itself. That is, dash a equals to a. We also have D Morgan's law, which was beautifully explained by one of my colleagues, Ayush Mishra. Just to recap, the D Morgan's law states break the line and change the sign. In the first example, right here, we can see dash a and b equals to dash a or b. The and operator turned into the or operator, and the dash came over both the Boolean variables. Now, this is a sample Boolean question. Dash a dot. The dot here also, the dot is an operator. It is a sign which refers to the and operator. In this expression, we can see the expression is dash a dot dash b plus dash c. When we simplify it,
it becomes dash a plus dash over the expression dash b plus dash c, which is governed by the D Morgan's law. The D Morgan's law states that break the line and change the sign. So the dash was broken into two. It came over a and the next expression, and the dot was converted into plus. Then again, by De Morgan's law, we get dash a plus dash dash b dot dash dash c. Then the final expression which we get after applying the involution law is dash a plus b dot c. The involution law states that two dashes make the variable itself. Here dash dash b became b and dash dash c became c. Thank you. This was all from me on the topic uh, simplification of expressions using Boolean laws. Thank you.
Okay, now open your camera.
Yes, sir.
Okay, now close it. Any other student who want to give presentation today? No. Rest of the students which have not given, they try to give their presentation as soon as possible. Now be attentive. I am calling the roll call. Anchal Kushwaha. Anchal Kushwaha. Aditya Jaiswal.
Present, sir.
Akash Verma. Next, Alok Bhaskar.
Yes, sir.
Anurag Semwal.
Yes, sir.
Next, Anchal Archana Yadav.
Present, sir.
Astha.
Present, sir.
Next, Ayush Kumar Misra.
Present, sir.
Next, Kanchan Saxena.
Present, sir.
Next, Manvendra Pratap.
Present, sir.
Manvi Kashyap.
Present, sir.
Meenakshi Sharma.
Present, sir.
Neeraj Misra.
Present, sir.
Right. नीरज मिश्रा हो गया?
Yes, sir. Present, sir.
ठीक. निरंजन यादव.
Yes, sir.
आयुष मिश्रा.
Present, sir.